and welcome to today's e-seminar on simulation of electromagnetic pulse, or EMP, with SIMULIA CST Studio Suite. So just starting off with a bit of a background. So the President of the United States recently issued an executive order on EMP. So it's a hot topic at the moment, especially due to the recent rising global tension. On the military side, the EMP has been well studied, but there is not much exposure on the commercial side. So it's known in the early days that electromagnetic pulse is produced by a nuclear explosion when testing nuclear weapons. During the first nuclear test in the United States in 1945, Enrico Fermi knew to shield the electronic equipment because he was expecting the EMP. And today we're going to put our focus on high altitude EMP, or HAMP, due to nuclear detonations. So the first demonstration of the significant effect of high altitude EMP was carried out in 1962 during the Starfish Prime test, where a 1.44 megaton bomb 250 miles above the mid-Pacific Ocean was detonated. The electrical damage included 300 streetlights being knocked out, numerous burglar alarms being set off, and microwave links damaged in Hawaii, which is about 900 miles from the detonation site. So the Starfish Prime EMP magnitude in Hawaii was relatively small, at about 5.6 kilovolts per meter, due to the Earth's magnetic field over the United States, and the magnitude of the EMP would have been much larger, 22 to 30 kilovolts per meter, if the detonation had been over the northern United States. The Soviet Union also performed multiple tests in 1962 in Kazakhstan, which includes current surge in a long underground power line that caused a fire in the power plant in the city of Karaganda. So a high-altitude nuclear detonation can produce gamma rays within the device. And these photons in turn produce high-energy free electrons by Compton scattering at altitudes above 20 kilometers to 40 kilometers. These electrons are then trapped by the Earth's magnetic field, giving rise to an oscillating current. It is this current that produced the rapidly rising electromagnetic field called an electromagnetic pulse, or EMP. So the high-altitude EMP is not really generated within the weapon itself, but outside of it. And from a distance far away from the detonation, the generated electric field is uniform, which we can model as a plane wave.